So it's 1 minute over 2 p.m. So let's start. My name is Miroslav Shamera. I will introduce you to this webinar shortly, and then a colleague of mine, Karl-Henrik Rittersson, will show you the software. I maybe turn off camera so you can see me some few seconds. Hello. And we will talk about model-based quality process, or how to digitalize your metrology processes. I just want to inform you that we are recording this webinar, and also if you have some questions, we will have 5 minutes at the end of the session, so you can unmute yourself and ask questions. For now, everybody is muted, but if you have questions, you are welcome to write them in the chat. So let's go with the presentation. I will start with short introduction of Ariadne Engineering. So we are a consulting company based close to Stockholm. And by the way, we've got people out from outside of Sweden. That's why I'm holding this seminar in English. So we are based close to Stockholm, and our mission statement is to help our customers to create high quality products. We would like to do it efficiently, and our idea is to use model-based definition, model-based environment concept, utilize your digital models. So the CAD model you see in the middle of this circle, it's a start of a journey. We would like to use it for final element simulation, product specification, of course, using ISO GPS, intelligent information management, tolerance analysis, lots of stuff basically. And one of them is quality control. We would like to digitalize those processes and finally automize them. We have ambition to support the whole process, and we do it by delivering software, consulting services, training, and support. We work with following partners. Anarch is an American company developing software for information sharing, intelligent information sharing. MBDVidia will be actually the central point of this presentation. Company developing software to supporting metrology processes. And finally, Sigmetrics, it's automatic tolerance analysis with a main product CTOL 6 Sigma for 3D tolerance analysis. Let me tell you shortly about MBDVidia. MBDVidia is actually a company behind the new ISO standard QIF. So they developed the standard. They do work closely with ISO committee, ANSI committee, 3D PDF consortium, and other companies setting rules for information transfer, so to say. And they also work closely to major CAD vendors like PTC, Siemens, SolidWorks, and others. The software based on QIF format is supposed to support metrology processes. And what is the value of automatic inspection? I would say that we would like to cover everything within product development, from design, manufacturing, and then quality control. We would like to go upstreams, so capture processes and automize processes. And then we would like to also go downstreams, so unlock the measurement data for design department to improve the product, not only use it for go, no go decision, but unlock the knowledge which is there. So looking at the upstreams processes, of course, we would like to eliminate human errors. We would like to eliminate manual parts of the process and make it automatic. And when looking downstreams, everybody's talking that new gold or oil is information. So the highest rated companies on the market are companies like Google, Facebook, and so on. So they do deal with information. And we believe that when you measure your parts, it is very good source of information about production processes, about the robustness of your product, and so on. If we can unlock this data and use it to improve products, it might be worth a lot of money. So let's go further. Current state of metrology processes is we can claim that it's mainly manually processes. So information also will be used for just go, no go decision. So it's just verification, not added value, so to say. So imagine that we can work with regard to digital twin concept and have full control on geometry connected to the design model. We can unlock data, maybe apply artificial intelligence to find trends and to improve our tooling, improve quality and robustness of our products. And so this is the intention. And the base for this is QIF format. So QIF is the information barrier carrier, sorry, information carrier created for supporting metrology processes. So it's very similar to step 242 in terms of geometry. So we can save geometry with 3D PMI data with tolerances, but we can also put bill of characteristics. So what we should measure, what is critical, and so on. We can save also hardware resources, best practice, CMM programs using DEMIS language. We can also save measurement results and perform statistical analysis of the results and reconnect it to the CAD model. So basically on the CAD model, you can see measurement results, you can compare different suppliers, you can complete different batches and so on. And QIF is ISO standard since a couple years ago. So once again, current processes, probably you recognize the picture to the right. You start with very often 2D drawing on paper or in PDF, and you have to measurement guy, metrology guy must interpret all the specification and translate it into metrology software. Of course, it requires high skill of a guy. It requires lots of time. So the process will be manual, people dependent, and labor intensive. Also, it means that we will make a decision, go, no go, and kind of save this data somewhere, but not use it. So we would like to propose an MBD-based approach, and basically data will be transferred from the CAD model to the measurement machine. We will eliminate all translation errors and so on, providing that we have good quality of data in CAD, and also we will unleash the results. We can do analysis of the results and improve our products. Today, we can suggest two flows. One which is totally automized. So the lower one, MBD directly to CMM machine. And this requires very good quality of your specification in 3D and probably tweaking of the software. So all the softwares can speak to each other. The other way is to use QIF and through QIF go to Excel, create first article inspection protocol, which is customized based on your industry standard, and let the measurement guide to fill out this document, and we can save it into QIF and import to CAD. And this means that we will unlock the results, we can evaluate them, we can make them traceable, and so on. And here is the example for model-based automized process. You see Creo and CapVidia software working together. and then transferring data to the software, metrology software called Checkmate. This process was entirely automized, so it's possible to do actually. Here is an example for results. What happens when you do automize your metrology processes? We are very often talking about 80 to 90% of time reduction. I will not go into details of this project. If you are interested, please contact us. But here you see NX and on CAD side, MBDVidia and Zeiss Calypso on the metrology side with 97% time reduction. So quite impressive results. And the other semi-automatic way, which we will show you today, it's more robust. It's based on QIF models. So from the CAD specification to QIF, QIF will generate bill of characteristics in Excel. We will populate this Excel with measurements and send back to QIF and to CAD, and be able to evaluate the results. And this process is pretty robust and simple, so that's why we suggest it. It's a very good starting point. And also, we can apply this process to 2D PDF drawings. So MBDVidia is using optical character recognition technology, and we make your dead drawings digital and also do basically the same stuff as with 3D models. So there is no reason why to wait with this semi-automation of your metrology processes. So I hope it sounds good, but of course we would like to prove it by showing you the software. So now it's time for 15 minutes demo, and I will switch to Carl-Henrik in practice.
Thank you very much. So basically I'm going to show you what Miroslav talked about. So I'm going to show you mainly the software MBD-Vidia from MBDVidia, which is going to enable us to create standardized and traceable measurement reports, first article inspection measurement reports. And I'm going to show it to you both ways. First, we're going to look at that full automatization doing it. So starting from a CAD model with PMI, so-called MBD. We're opening that in MBDVidia, and by that, it's going to automatically generate a bill of characteristics containing all your requirements with numbering, ballooning, and it's going to be stored in a QIF file. So what we can do with this one is that we can do several things with it, but one thing is that we can export this to an Excel format, an empty report, so to speak, which we can then give to the supplier, and the supplier can then fill it in. And because there is traceability in all of this, the QIF knows that this Excel file belongs to it, and the QIF also know it belongs to a certain CAD file of a certain version and a certain revision. So we can then import the information back into the QIF and do some simple evaluations with it. So, and by doing this, we can, by standardizing measurement report like this, we can easily then compare different suppliers to one another, and also different revisions of components to one another. And because we make the data traceable, we know which version it belongs to, so it gives us control over the data. And as well as this enables us to make the measurement data more available than before. So not only quality engineers can access this and use this information, we can also make it available for instance, design departments. So design engineers can use it to create better products. So, and this is a great way of bringing value to your MBD efforts. So second demo I will show to you is using what Miroslav talked about, using it before practice MBD in your CAD models. You might want to use your 2D PDF drawings, and you can benefit from same with a semi-automatic process by using optical character recognition technique in MBDVidia to create standardized measurement reports. And then we can use the same scenario. I will also slightly address what Miroslav also talked about. The holy grail is, of course, in the end, to fully automate this, not only to create automized measurement reports, but also to use this information, the QIF, to automize the metrology processes. So automatically program the metrology processes, as well as populating the report. So we want to send the QIF directly to the supplier. But before we do that, we want to make sure that the quality of the data is good enough, so that the PMI, the annotations in your CAD model, are well defined. So let's get started with a demo, and we're going to start off with this is my CAD model, and it contains PMI. So we're going to use that. Use the MBD approach to create a measurement report. So from this, we can open directly in MBDVidia, and it's going to look like this. So it looks like same model, the same PMI coming in here, but with the difference here that we have something called a bill of characteristics at the bottom of the screen here. So it has automatically created a list of all the requirements, a bill of characteristics, and I've also given a number to each one of those requirements. So this is the benefits of using MBD. It gets automized. So what can we do with this then? Well, in the end, we will send this QIF file directly to the supplier. But before we do that, you might consider using an Excel approach. So we can click Export Excel here. And you're going to receive a Excel format of this report, which looks like this. You have several formats to choose from, and you can also create your own appearance of this. This is called ICE here. And you get the same list you saw just previously, but also you will get pictures that was auto-generated because it's MBD. So you have everything you need in this Excel file. You don't need any additional 2D drawings with PDF or anything. Everything is contained here. So we can now give this to the supplier, which manufactures the products and then performs the metrology processes, the inspection, and fills in this list. And now because of traceability, this Excel file can be reused. We can import the data back into our QIF. So now if we go back to the MBDVidia application, previously we used export. Now we can use import and import that data coming from the supplier. We can even have different batches and tell them apart. So so here we can see some results popping in here, and I'm going to import 2 batches here so you can see the difference. And let's say that that's a new batch, and it also contains some simple tools to evaluate the results. So as you can see here is something called thermometers, and we can also look at capability values, CPK and PPK and such, and more. So this is a way of dealing with reports with full optimized scenario. So and now you're wondering, can we do the same in when we don't use MBD using 2D PDF? And of course you can. So what we can do in MBDVidia is, this is the second approach, the demo number 2. So now we're starting from a different point of view here. So I'm open a regular PDF. So this is a regular PDF containing the usual annotations on the drawings. So we can then use character recognition technique to scan this drawing and populate the bill of characteristics. So it's currently empty. So I'm going to press auto capture here to try to capture all the requirements in the drawing at the same time. So it's actually scanning the graphics in the PDF and tries to convert that to recognizable characters. And you're soon going to see it's going to highlight certain fields in the cyan color, and it has actually identified lots of requirements here. So this is MBD is higher quality of data. So before you go ahead and send this protocol to the supplier, you want to make sure the annotations are captured correctly. So I want to approve each and every one of these suggested requirements. So how do I do this, Joe? I'll look in the graphics window to the left, and then that's graphics. And then I look to the right in my preview window, and that's what the recognized characters are. And if they match, I'm happy. In this case, they match, so I just press approve, and it gets green. It's approved. The next one also is a match, so I approve this one. And this one also matches. So I keep on doing this until I get to something like this. And here it has not succeeded. So I'm going to, it scanned it in horizontal direction. It should have been scanned in vertical. So I'm going to help it and say that this is not the QO, it's an actual dimension, and it has the number 8. So now it's fixed, and I'm going to approve that one. And then I keep on doing this until everything is approved. I can skip to the end by approving everything. I wouldn't recommend doing this, but well, it's a demo, so we can do it a little bit faster. And then we keep doing this for all the drawing sheets. And finally, we're going to end up with a complete one. It looks like this. So here I have all my requirements, even the general requirements, turned into the bill of characteristics. So all my 3 sheets here. And well, from here on, it's the same methods, same workflow as for the MBD approach. We can then export it to Excel and then import it back once the supplier has filled in the reports. And we can evaluate the results the same way as before. So this is a very quick demo of how these 2 scenarios work in MBDVidia. And then I get to the holy grail. We want to fully automate this, so not only create reports automatic, but also we want to use the information in the QIF to automate the entire metrology process. So, but before we can do this, we want to make sure that, for instance, the PMI here have good quality so that the metrology software knows what to do with it. So also we might want to feed in some information about also which measurement device to use and other types of metrology information along with it. Save it and send to the supplier. But how do we control the PMI, the quality of the PMI? Well, there is a function here, of course, in MBDVidia, so which I'm going to show to you. So let's do that. So there's a button here called MBD Ready Check. So I'm going to push it. And what it does now is that it checks all the PMI and checks basically that it's MBD ready, that it has sources referenced, all the annotations and things like that. Syntax are okay. So in this case, it says 97% score. So it's not 100%. And there are actually 2 annotations which has some issues. So let's bring up the list of this. And here you can see that there's one here with an incorrect feature counter. So if we double click this, it's gonna show us which annotation this is all about. And it seems to be this one for the 2 times the whole 8.4. And I can see that it's incorrect feature counter because it's 2 holes, but it only references one of the holes. So, well, now we can decide if you want to go back to the CAD model and, well, revise it, of course, modify it. Or you can choose to, if it's not a major error, we can also use the repair tool in MBDVidia. So we can actually fix the problem here if it's too much of a process to revise the model, or if the error is not big enough to do that. So now it's fixed, so we can now redo the check, and this time it's 100% score of it. So, and there's more to this, but since we have limited time in this webinar, I will now go on to the 5 minutes of questions, if you have such. So that summarizes my demo.
I just want to also summarize. If you use your model-based definition in a metrology context, you can reduce the cost of inspection, you can reduce the time of inspection, increase quality because we avoid manual errors. We can unleash the measurement information and bring it into digital thread, open it up for product improvements. And of course, we'll eliminate all the data transfer errors. So it's worth to do it. If we go forward even more into the future, so we can also connect measurements to tolerance analysis. So in the proposed scheme, we do tolerance analysis on your 3D model. It's pretty simple. When you have 3D PMIs, you will find critical dimensions to control. So this will be the base for your inspection plan. And when you do the quality control, save result into QIF and find realistic measurement-based data as an input for tolerance analysis and refine tolerance analysis and improve your product. So it will be kind of closing the loop, connect reality to theoretical analysis. And everything will be in your 3D model, traceable and so on. How to start? If you are interested in these issues, please contact us. We will probably suggest starting with Excel-based, QIF and Excel-based semi-automatic method, but we can also take a look at full automation if you are interested.